About a year ago I fixed a Pioneer Laserdisc player, but at least I thought I had. It's come back with the same fault. The DVL919E was one of the later models to come to the market, and you can see that this plays DVDs, CDs and Laserdiscs. And this one in particular is rather special because it plays both sides. Or at least it did when it left here last time. I need to find another way to fix it. And off it comes. I'll stick some power in this and plug into one of these SCART lead sockets and turn it on. It's doing its little dance now, seeing if it can detect a disc, which it can't. And if you haven't seen part 1 of these and don't know what a laser disc is, you're in for a shock. So here I have a laser disc. They look like a giant CD the size of an old LP, and they hold an entire film on them. So of course we have to press play to replicate the problem. Okay, so here it is playing. We get the obligatory copyright notice. I think we can skip that. There we go, we have a film playing. As you can see, there's nothing wrong with it. Not much in the way of sound, mind you. Okay, so what we need to do is to see the fault, because this actually plays fine. If I skip through, it takes it a while because that's the technology. Okay, if we flip to side B,
Captain's log, stardate 48632.4. Dr. Crusher has informed me that Data's emotion chip has been fused into his neural net and cannot be removed. However, she believes he is fit for duty, so I've asked him to join me in telecartography. According to our information, the ribbon is a conflux of temporal energy which travels through this galaxy every 39.1 years.
so here we can see the thing is stuck. The laser sled's not moving at all. This is what happened before. If I press fast forward, now all of a sudden it's moving just fine. Doesn't have a problem now. So that is a bit strange. A common cause of this is a broken plastic part called the M-holder. The M-holder or motor holder is a gear casing for the sled drive, which incorporates a plastic shaft which is prone to shear off. However, that tended to happen on the early models with a grey plastic M-holder. Newer models, including this one, had got a black plastic M-holder. And as we saw, it hadn't failed. So I'm just going to eject this disc because I need the tray out of the way, because I've been in here before. This top board's actually the controller for the DVD player, and the DVD pickup is the one on the top here. It's almost a separate machine in here. The Laserdisc player is actually controlled by the board at the bottom, so I need to clear some boards out of the way so I can get at it. So I'm just going to unplug some of these cables. Carefully with this one. Pop 4 screws out. Just unclip this cable tidy little thing. So now the board can lift out. I've just spotted these nice little clips here to stand the board in. Isn't that nice? Although I do think these ribbon cables are still in my way. So there we go. That's the board I'm looking for. The laser pickup assembly along with the sled is connected by this ribbon cable in connector CN801. What I've got in mind is to see if I can drive the sled with a little bit more oomph. But I need to understand how it works before I can tell you if that's easy to do. So this board is a CLDM board. So we're back to the schematics. We've got the service manual for the DVL919 and we're looking for the CLDM board. Scrolling through the service manual till I get to the relevant page. And here we go, CLDM. Right, we're now looking for the connector CN801. Here we go. This is it here. We can see at the bottom we've got the sled drive here on pins 26 and the return on 27, which is just grand. Zoom in on this a bit. We can see the sled drive comes out over here. It's actually the output from this chip here, pin 1. So this is IC803, which is an LA6510. This is actually a dual op amp, but a high powered one. Outputs 1 amp, don't you know. So you definitely want to be probing pin 1, so actually test point 1, see what's going on there. That'll be the output directly to the sled motor. And just like any other op amp, they're 2 inputs, inverting and non-inverting. The non-inverting input is actually called 5/2 volts, which makes me wonder where it came from, because it's also used up here and down here. And I did think it was actually a switch, it's either 5 or 2 volts, but then I realised there's a potential divider network here. 47k to ground and 47k to the plus 5 volt rail. So it's actually 5 divided by 2 volts, otherwise known as 2.5 volts. Why they just couldn't write that, I don't know. So if you follow this signal, SLDO, I guess that's sled output. See where that goes. And here it is, pin 18. It comes straight out of IC101, the mechanism control microcomputer. Well, we should be probing that as well. So on this table they very helpfully explain the pin functions for this chip. And pin 18, the sled drive, is an output. It's a pulse width modulated output. And it's the slider control signal output. 5 volts equals forward, 0 volts equals reverse, and 2.5 volts is stop. There we go. That'll be 5/2 volts. I also want to probe the tracking drive, which is on pin 25, TRKD. That powers the field coils that moves the lens backwards and forwards. And here it is, similar arrangement. This is pin 1 of IC902. Now we know where to look. This chip's quite easy to find. We've got IC171, IC803 and IC902. And whilst it's easy to put the oscilloscope probe around here, these test points, I'm going to have difficulty when the laser disc draws closed. It's going to cover this up completely. So I'm going to have to take the board out so I can solder on some test points. So first to come out is this composite video board. Just lift it out from the back and pull. Just unplug this ribbon cable. Also going to take this bar off. Sort of feels in the way, even though it probably isn't. Oh, it's also holding this board up. Let's get this cable tidy off there. Still needs to be loosened. That should flick off now. Yes, it does. It's under these ribbon cables. So unplug this for the DVD control board and the digital outputs. I think this is in my way as well. Nearly there. 2 more ribbon cables. This is CN803, the laser disc pickup, and something to do with the mechanism. Switches probably. Oh, nearly forgot about these. Board won't come out if I don't undo them. Then we've got these plastic spring clips to undo. And that should come out now. Lovely. So just to make it clear, I don't think there's anything actually wrong with this board. I just want to see what's going on. You know, the sled motor's powered by this chip here, and it comes out of pin 1 right on the end. And it gets its commands from this chip here, on pin 18. We also want to probe the tracking coil. That's the thing that moves it forwards and backwards. Well, not up and down as well. That's the focus. It's all very springy. You can see it just about gets to pin 1 under there, but on this one here for the tracking drive, that's too close, can't get to it. However, looking from underneath we can see pin 1 of the tracking focus goes up through here onto this string of wires there. That's handy. Similarly, pin 1 of this chip for the sled drive goes around, snakes around here. And on this row, those look like good places to stick a test point. I just want to scrape off the solder mask off the top of this, so I can solder a test hook on. Just tin that copper with some solder. Flux in it will also clean it up a bit. Same with this one. To make a test loop I'm going to use this 24 gauge wire and wrap it around the end of the screwdriver, forming a nice neat circle. And join it together with a little blob of solder. So now pull that off and we've got a nice little test loop. Now I can solder the test loop onto the bared off tracks. Same on this one. I've offset them so I can get my scope probes in. There we go. Probing pin 18 is a little bit easier. Just use one of these fancy clips. Let's hope it lies down flat enough. Can now put this board back in. Keep the ribbon cables on the top. Let's get this ribbon cable in first. And this one, slightly hard to reach. And these two overlapping ones. And down like that. This one I think went over the top. Bit of a zigzag to it. Then the SCART socket module. So I'm going to want 3 probes, one for the sled output, one for the sled input from the microcontroller, and also for the lens tracking. So I can use my test loops. That's the sled, that's the tracking, and this is the sled command for the microcontroller. Let's plug this back in, don't know if we need it, and sneak it back in place. Put these 2 ribbon cables back in off the DVD controller board. Let's pull the board back nearer to its original position and pop a couple screws in. So let's turn it on and see what's happening with the signals. We saw a bit of life then. We can see the blue line, that's the tracking signal, a bit of a sine wave to it. That's because of the wobbly disc. The green line's far more digital because that's the output from the microcontroller telling the sled to move. The yellow trace is the actual motor supply. So that's what it looks like functioning properly on the A side. We swap it over. We can see an element of overshoot in this as well. You can see the command sort of coming and going, sort of swelling in the trace there. That sort of swelling wave is a bit larger to my eyes. Yeah, it's sort of getting a bit bigger, as if it's getting a bit tighter there. Oh, there we go. Look at that. It's no longer coming and going, it's just on. Did you see the blue trace then? The blue trace just jumped. That's where it's trying to reset its position. And again, this is it glitching. So it's trying as hard as it can to shift that sled. Well, I'll say as hard as it can. It's putting no extra effort in. None at all. If I zoom back in with the green trace, we'll see if the PWM duty cycle is changing. It's not at all. What is that? 10%? 15%? It's not actually trying any harder. Interesting. Oh, we'll stop it there. So now we've seen the contactor getting a little bit more voltage to make it move is going to work. So how are we going to do that? I've noticed the pulse width modulation doesn't change duty cycle. Now that's going to be quite difficult to adjust that. I don't think it's adjustable at all, to be honest. Maybe I could make a circuit that extends the duty cycle, but it's getting a bit complicated. I think the other way around is to have a look at the analog side of it, see if it's been amplified. So you can see the sled drive output here. This is the PWM signal, sort of fixed at 15% duty. It's fed through R151, which is a 33k resistor. Now, like any operational amplifier circuit, we got feedback. The feedback, which sets the gain, is here, R156 100k. We can analyse this little bit of circuitry and see what the gain is and see if we can adjust it. I'm just going to draw that amplifier circuit out, see if we can simplify it a little bit. We know it's got a fixed 2.5 volt reference voltage, 5/2 volts. It's got a 33k input resistor and a 100k feedback resistor. There's also a 100k pull-up resistor connecting it to the 5 volt rail. Now this makes a pretty standard inverting amplifier circuit. When the microcontroller gives its high signal to tell this to drive, it essentially connects the 33k resistor to the 5 volt rail as well, putting these two resistors in parallel. We can quickly work out what the equivalent resistance is for a 33k and a 100k resistor in parallel. And that's the product over the sum. That's 24.8 kilo ohms. So the equivalent circuit looks a bit like this. And the gain will be negative because it's the inverting amplifier, but it's the feedback resistor divided by the input resistor. So that's minus 100 over 24.8, which is about 4, minus 4. We know in the high state that this is actually plus 5 volts, but the reference here is 2.5 volts, so it's actually the same here, 2.5 volts. So at this point our output voltage should be minus 4 times that, so minus 10 volts. But it's not, as we saw, it's nowhere near that. And the reason is there's a capacitor here, 10 nanofarads. This turns it into an integrating amplifier, which means it's going to turn a square wave into an inverted triangle wave. So in this case the gain we've seen isn't a true gain, it's almost like a ramp selector. Well, we need to make this steeper, and we do that by either increasing the feedback resistor value, making it larger than 100k, or reducing the input resistor, making it less than the 33k. We could also make the capacitor smaller, that would also steepen the slope, but might run into other trouble doing that. But as we don't really know what we want, I think it's easier to reduce the input resistor, this 33k one. I could always wire something parallel with it, especially when I don't know what value I want. I'm going to have a little play. So let's have a little hunt for this 33k resistor. No, we don't need to probe this anymore. We need to move this out of the way as well. Pull this board back out of the way. And fetch our probes off. Oh. Not like that though. That's not the worst thing, but that's not good either. And this one's told us all it's going to as well. Careful I don't destroy this ribbon cable whilst I'm at it. I'm in enough trouble as it is. Well, I've torn half the pad off the board with my test hook. That was not the plan. Well, I need to rescue this. But we'll get the old solder up so I can see what's actually going on. This gives me that sinking feeling, like imagine pranging your car when you're trying to park it into another car that you own. Let's clean that flux up. So that's making it look like it's stuck down perfectly, and I know it's not. There we are, we can see what's happening now. So we've got the track from the driver chip on the bottom side of the board, that comes to a wider part, and on the top side, which goes to the motor, is a matching side. And they're joined by 4 little plated holes called vias. The vias are actually drilled holes with a very thin layer of copper plating on there. It's so thin we have to put several on there for it to carry any current. What my little accident's done is disconnected the top track from 2 of the vias. I need to re-establish that electrical connection, even though it'll still measure 0 ohms. So on the motor side, I've got to scrape some of the solder mask off like I did before. These are called protected vias because I've actually got the solder mask covering the hole over, which is good to stop things like corrosion, moisture getting in the via and corroding it from the inside. It's not great for me now. So I'm going to need the microscope again, it's getting little. Got some tin copper wires at gauge, see if it goes in the hole. It does easily. This is 0.3mm diameter. So I've got a little drill bit, it's 0.4mm diameter. I'm going to put it through then, very carefully drill that out, going very steadily. This will actually wipe out the via, I reckon. There we are, we're through. Got to do it again to this one. And this one's through as well. So we just push our damaged track back down. Hopefully we don't tear it. Hold it still. So what I'm going to do is try and feed this wire through that hole. Like that. So now that wire's come through this side, I can bend it over. Push it in. So I'll pull that through. Pull it tight, and that should be tiny. It's a bit like doing a suture. Maybe I should work on people. Now I just need to solder that up. I never tinned it to begin with. There we are. See if it'll solder over the via holes. Probably not. But that's done enough. Let's pull this up. Snip it as close as I dare. Same that side. Now to solder this side up, and we're done. Still with my test loop on though. I'll try not to break it next time. So anyway, let's go back to finding these resistors. Are these them here? Let's bend this out of the way a bit. Well, there's a chance. That's 33k there. 100k. Let's find pin 18 again. Check. Is this side on the chip? Yes, it is. Well, that won't read anything anyway. Yeah, pretty sure that's it. I've got this natty little wire dispensing pen here. Very useful for things like this. You've got a little break on it. Let's just clear a little bit more room to find the wire in its right place. Just there. I'll just touch the iron on it. There we have it. Pull that wire out. Just snip that off. Just tin the end of this. And just feed that one in. Tack it there. That'll do. Just snip this one off. Just gently bend these wires so they go this way out the board. It's a bit better. Also move this out of the way a little bit. I don't want that screw touching on the heat sinks. Just going to tin the ends of these, which also melts the insulation off. I can barely see them, mind you. I'm just going to solder thicker wires on there so I can see them. Just slide some rubber sleeves over the joints. Taps that blobby soldering, holds it in place. Nice. Just tape these down over here, just keep them out of the way. So let's put our board back in with its little mods. Carefully put the probe on again. I'm going to connect this decade resistance box across those 2 wires so I can dial in various resistances. Plug some test leads in here. Clip one on here and the other one there. This is set to some arbitrary high value, 700k. It's not going to have any influence across a 33k resistor. So we can put our disc back on, then power it back on. Press play. Switch to side B.
Captain's log, stardate 48632.4. Dr. Crusher has informed me that Data's emotion chip has been fused into his neural net and cannot be removed. However, she believes he is fit for duty, so I've asked him to join me in his telecartography. And get magnetic fields. Wait. The bosun are structure of the Amadeus has altered the gravitational forces around the sun. As a result, any ship passing through is reaching.
There we go. It's stuck. That's what I'm looking for. And now I can decrease the resistance on the decade resistance box and see if I can shift a bit more voltage into this motor. Start with the 100k range, go from 7 to 600, 5, 4, 3, 2, 100. It's still stuck, it's made hardly any difference. Line this up to 90k and then down to 0, so now got 90k on there. And it's just gone. Is that enough to keep it going? It could be. Well, so far so good. So what is that resistor? It's actually 98k we got there, times the 33 that's already on the board. That's the product times the sum. 24.68k. Well, the nearest I've got is 22k. So now I've identified what our mod's going to be. We're going to change R151 from 33k to 22. Which of course means we're going to open it up. I need the drawer out of the way. Take the disc off. Power off. Disconnect our test leads and take it all apart. So we can take this tape off now. So I can disconnect the wires. There's one. There's two. Now to desolder that resistor, it's a bit narrow even to get the soldering tweezers in. Try and solder both ends at once. Get the tweezers in there. Let me pull it away. Got this handy selection box to surface mount resistors. Let's flip the 22k lid open. Pick one out. So I'm going to tidy that mess up. Let's put a bit of solder flux on there. Let's get our resistor into position. It's about there. So I can get the soldering iron in there. There we go. Just wipe that off. There we go, all tidy. Might wipe some of this flux up. Not that it's a problem. With a bit of IPA on it as well. There we go. Just straighten these up a little bit. So I think that's it. Well, I hope it is. The mod is only one resistor. A little bit awkward to get at. But yeah, let's put it back together. You should all be very good at whipping this board in and out yourselves now. You've seen me do it enough times. Have to keep all these ribbon cables out of the way of the tray. Well, that's not too clever. Looks like the backing has come unglued on this. I'll soon fix that. Put a drop of super glue under there. That's better. Slide this card back in. Hopefully for the last time. Now I can put that bracket back on. So it sits like that. lift this board a bit so I can tuck that under there, get the clip lined up. There we go. And then the DVD board back in. We'll just give it one final test before the lid goes on, make sure nothing's gone wrong. Well, it's doing its thing so far. The side A was never the problem, was it? Let's try side B. I do love that mechanism.
Captain's log, stardate 48632.4.
And the trouble tending to start around the 30-second mark. Let's see how we get on.
Euro net cannot be removed. However, she believes he is fit for duty, so I've asked him to join me in stellar cartography. The ribbon is a conflux of temporal energy which travels through this galaxy every 39
No trouble so far, this is looking promising.
This center, approximately 42 hours. Yes, Guided was right. She said that Solomon was trying to get back to the ribbon.
I really don't know how much I need to watch to be sure it's fixed, but I think we're about there.
Is affected by the star's destruction, no matter how it's It will take the computer a few moments to compile the information. Did the computer take that into account when it projected the course of the ribbon?
And we're now up to the ribbon and still no glitching. I think it's good. We'll stop it there. Let's take the disc out for the last time. Well, it all looks like it works as it should. Let's take the cables out now. So, lid back on. Hopefully I don't see this again. Just these shiny case screws now. Well, I'm calling that done. So there you have it, a little engineered bodge. Hope you enjoyed it, and I'll catch you next time. Let's get our resistor into position. This I can see. That's the wrong resistor, Mark. What an idiot.